Tonight we're going to look at the laws of exponents, and we're going to use these to simplify exponential expressions, or expressions using exponents. The first one is the law of multiplying like bases. We looked at this in class today, and we found that it said to keep the base and add the exponents. And symbolically this says a to the m times a to the n is equal to a to the m plus n. And we basically use this law to simplify. We want to easily find the value of multiplying two or more of the same base together with different exponents. So we really just want to use these to find values. So here's an example of positive exponents. We want to simplify and find the value of 2 cubed times 2 squared. And what we do is we keep the base and we add the exponents to get 2 to the 5th. And 2 to the 5th is equal to 32. We have an example with negative exponents, and we also want to simplify and find the value of 3 to the 4th times 3 to the negative 2. And here we do 3 plus, we keep the base of 3, we add the exponents. 4 plus negative 2 is the same thing as 4 minus 2, which equals 2. So our base is 3 and our exponent is 2. So we have 3 squared, which is equal to 9. I want you guys to take a moment, pause the video, and practice with these. And here are the answers. And I want you to try these on your own. You will be given the answers tomorrow in class. I will pull one of these questions for your warm-up. So I want you to pause and try these on your own. The next law is the power to a power. So we're raising a power to a power, raising an exponent to an exponent. And the law of power to a power says to keep the base and multiply the exponents. So if we have the base, if we have a to the m to the n, we're going to do a to the m times n. And we use this law to simplify and find the value of a base being raised to two exponents. So for example, with positive exponents, we want to simplify and find the value for 2 cubed squared. So we have 2 cubed squared, so the law tells us to multiply the exponents. So we have 2 to the 3 times 2, which is 2 to the 6, and 2 to the 6 is equal to 64. And here's an example of negative exponents. We want to simplify and find the value of 3 squared raised to the negative 1. And this is a really special one because we have to make sure we get the fraction. So we have 3 squared raised to the negative 1. We multiply those two exponents together, so we have 3 raised to the 2 times negative 1. And a negative times a positive is always negative, so we get 3 to the negative 2. And 3 to the negative 2 is equal to 1 over 3 squared. We just move 3 to the negative 2 to the bottom of the fraction and make it positive, and we get 1 over 3 squared. And 1 over 3 squared is equal to 1 over 9, because the bottom is 3 squared, and 3 squared is equal to 9, so the bottom's going to be equal to 9. I want you guys to pause and practice these two for me. And here are the answers. And again, I want you to pause and try these on your own. You'll get the answers tomorrow in class with your warm-up. The next law is a power of a product. Actually, I did not know this one existed until this weekend. The law of power of a product says to find the exponent of the numerical base, we just use the exponent we're raising the product to, and to find the exponent variable, we just multiply the two exponents together. Really what this means is we have a number and a variable raised to an exponent, and we're raising all of that to an exponent. That the number is raised to the exponent we're raising to, and the variable is equal to the two exponents multiplied together. So we have, for example, a to the xn raised to the n is equal to a to the n times x to the mn. And we basically use this law of power of product to simplify a product of two different bases being raised to an exponent. Here's an example with positive exponents. We want to simplify, we're simplifying because we have a variable, we're not finding the value of negative 6y to the 4th squared. So we attach the exponent of 2 to the 6 to get its exponent, so it's negative 6 squared, and we find the exponent for y by multiplying the 4 and the 2 together, so we get negative 6 squared times y to the 4 times 2, and that simplifies to 36y to the 8th. And here's an example with negative exponents. We want to simplify the following using positive exponents. We always want positive exponents with negative exponents. So we are going to actually move the whole entire thing to the bottom of the fraction. So we have 1 over 5x to the 4th squared. The 2 on the outside attaches to the 5 and attaches to the 4 for the exponent on the x. And so we get 1 over 5 squared times x to the 4 times 2, which equals 1 over 25x to the 8. You can actually go through and do doing everything first and then making it into a fraction, but I think making it into a fraction makes it much easier in the long run. And here's the practice. I want you to take a moment and pause and practice for me. And here are the answers. And I want you to take a moment and do these on your own. You will get the answers tomorrow on your warm-up. The last law is law of dividing like bases. The law of dividing like bases says that we keep the base and subtract the exponents. So symbolically, if we have a to the m over a to the n, we have a to the m minus n. And we use this just to basically find the value and simplify division of two or more like bases. An example with positive exponents, we want to simplify and find the value of 3 to the 10 over 3 to the 7. And 3 to the 10 over 3 to the 7 is equal to 3 to the 10 minus 7 because we keep the base, subtract the exponents, and we get 3 cubed, and we know 3 cubed is 27. Here's an example with negative exponents. We're going to simplify and find the value of 5 to the negative 3 over 5 to the negative 2. And we keep the base, we subtract the exponent, so we have negative 3 minus negative 2. Subtracting a negative is like adding its positive, so we get negative 3 plus 2, which gives us 5 to the negative 1. And 5 to the negative 1 is equal to 1 over 5 to the 1, which is equal to 1 over 5. So I want you to practice on your own, so pause and practice. Here are the answers. And I want you guys to do these on your own. And I do know this was a lot for one night, but we have the whole entire week to practice this. So I wanted to give you guys the notes tonight. And then so we can go through this next 3 days and practice these and make sure we understand how to use them to simplify expressions with exponents. So I'll see you guys tomorrow.